So we continue. Alright. So we use derive from the Euler equation. Jap. Saya punya pointer pen. Okay. So we use a Euler equation. So how do you to solve using Euler equation? We will talk about it later. Yeah, we will discuss it later. So by that, you solve this equation, and then you have the general equation. Okay. So from this equation, also same method, you put your velocity, initial velocity. So initial velocity, and then determine what is your initial time. Velocity. Initial times. Okay. Step size, we call it as a step size. Okay. So you can determine your total velocity. So how you construct Euler, we will discuss later. But there will be another method. In order to solve the same problem, you have another method. You have alternative. But not only one, but it can be many. I think about 5 to 7 methods, different method how to solve this problem. Okay, and depend on your which one you want to use. Okay, all right. So at the end of the day, you can have the same graph. Okay, so the question is, which one is more accurate? Okay, so we need to compare. This is by numerical, this is by analytical. Okay, so this difference we call it as a residual ataupun error. Okay, so after this we discuss what is the error. Okay, alright. So there will be some differences between analytical method and numerical method. Alright. So because each of the method have their own error. It's not error. We call it as a differences. So there will be some gap here. Okay. Alright. So that is the difference between numerical and numerical and analytical methods. Okay. So this is inside this chapter. Alright. So before we proceed, ada soalan berkaitan dengan analytical dengan numerical. Ada soalan? Semua okey?
Setakat ni okey je.
Okey, alhamdulillah. Nenek semua okey Dia jangan handphone je menyala. Orangnya tak ada. Jangan macam tu Okey. Alright. Ada soalan ke? Bunyi tu. Saya okey jangan risau Saya bukan Prof B40 Jangan risau Boleh tanya soalan. Contoh tu contoh. Okay. Alright, so inside this chapter, okay, so inside this topic, numerical methods, we have 5, 6 chapter. So chapter 1 we discuss on the root of equation. Okay, so this is your roots of equation. So what is the root of equation? That is your optimum value. And then when you talk about what is optimum, you talk optimum, optimization. So what is the optimum? Okay, so this is your optimum. Okay, this term is very popular when you do your FYP. Okay, so you want to optimize, you want to, it's not only the maximize but to optimize. So what is the optimum? So the optimum, you must reach this condition. Okay, you can solve mathematically. So that you can show that your study or your project is optimum based on root of equation. Okay? Alright. And then we have a system of linear equation. So how to solve this? The correlation between the two graphs. Okay? So this is the most common one. You want to define what is the intersection. So this intersection will tells you, okay, this is the right one, this is the lowest one, this is the optimum one, and this is the equilibrium condition. Equilibrium. Okay, so bear in mind that is your equilibrium condition. It has been exposed and being used widely. Okay, so that is chapter 2, system of linear equation. Chapter 3 is curve fitting. Curve fitting is how you want to define your graph. Okay, saya selit-selit contoh lah. Bila kamu buat graph kan, okay, majority kamu akan buat graph, lepas tu dia buat sini, macam ni, entah macam mana lah, lebih kurang macam tu. Lepas tu dia akan ada line. Tu ada satu line kat sini, contoh-contoh lah, ada ni, tu dia naik atas balik. Okay, ini Y, ini X. Betul tak betul? Ini graph yang biasa kamu buat kan?
Betul.
Betul. Pakai default dekat Excel, betul?
Betul.
Kamu belajar masa kamu SPM dulu ada buat graf macam ni tak? Jujur. Saya janji tak beritahu orang. Jujur. Ada belajar macam ni tak sekolah dengar lu?
Tak.
Tak ada kan? Kan betul tak? Kenapa masuk universiti ada belajar jadi?
Ajaran sesat.
Osar dah sebenarnya dekat AdMed.
Ha?
Dalam AdMed osarnya ada.
AdMed. Tajuk apa?
Ingat.
Jangan rasa-rasa weh. Kesian cikgu yang ajar tu. Okey.
Graf mana yang tak kena titik tu.
Yang kena titik ni. Titik ni yang kamu pakai default dekat Excel tu. Kan kamu sekarang buat graf macam ni. Terus direct macam tu je kan?
Oh. Aha.
Ada tak masa sekolah menengah lu belajar yang ni? Jujur.
Yang graf macam tu tak ada lah. Yang saya ingat graf yang gambar
Ni.
sedia.
Itu ada kan?
Yang graf yang selukis tu tak ada lah.
Kan. Tapi itulah, kat universiti kenapa semua pakai macam ni ya? Yang ni. Ini paling popular. Kenapa?
Sure.
Okay. Tak apa. Itu chapter 3. Kita akan discuss detail chapter 3. Jangan risau. Okay? Alright. So, chapter 4, we discuss on differentiation and integration. Okay? So, you has been introduced how to differentiate. Okay? Starting from your AdMed, Form 4, you have been introduced how to differentiate and how to integrate. That is the common one method. But here, you have 3 or 4 methods how to solve differentiation and integration. So, integration, I think 3 method or 4 method. How to integrate, how to solve integration. Okay, not only just tambah depan, kuasa kurang 1, tambah bawah. Itu kamu belajar kan sebelum ni kan. It's common, I know, common. It's not wrong, but you have another methods. Okay, alright. And then last is we call it as a ODE, ordinary differential equation. So apa itu ODE? Yang bila kamu ada X kuasa 2 campur X campur C, sama dengan kosong. So how to solve it? Okay, kamu buat dulu, ada pecah teknik paruh. Ingat lagi teknik paruh? Saya dulu pakai teknik paruh. Kamu pakai teknik apa? Darab 2 dalam kurungan, dapatkan dalam 2 kurungan. Ada tak? Betul tak? Masa sekolah menengah lu. Ingat lagi? Senyap.
Mana tak ingat aku.
Okay. So yang ni kita pakai another methods. Kita ada banyak methods. This equation we call it as a ODE, ordinary
Lupa dah tu.
differential. Faham? Biasa. Saya tahu. Melayu kan mudah lupa. Saya baik saya Jawa. Itu contoh. Okay. Selain daripada ni kita ada PDE, partial differential equation. So that partial differential equation is not within your scope. If you want to solve Lagrange equation, so you need to learn what is partial differential equation. Okay, yang tu tak masuk lah. Nanti kan kamu lagi pening. So we just only do ordinary differential equation. Okay, alright. So that is on the introduction to numerical methods. Okay, so we proceed into approximation and round off error. So in this topic we will use this term throughout the numerical methods. Okay, so when you talk about numerical method, so you must know what is the approximate and round off error. Okay, alright. So ini kamu baca lah. Okay, alright. So yang ni kamu baca lah. Alright, so what is the approximation and round off error? Okay, for many engineering problems we cannot obtain analytical solution. It's not the different. The simplest one, okay, you can solve directly by using analytical. But in real life, you cannot solve analytically. Okay, because the real life is much complicated. Okay, so that complicated, of course, this analytical is not we talk that analytical is not useful, so you cannot learn. No, that is the basic fundamentals. If you want to proceed with the highest, the accurate and also the more complicated, so you need the basic, you need the fundamentals. Okay, of course it comes from the analytical solution, but this solution cannot use for much complicated. Okay, it cannot be solved because it's too many unknown. Okay, so only one. You have been exposed, maybe let's say for example you're using a Newton's law. It's only 3 unknown: force, mass, acceleration. Okay, your acceleration is your gravity, 9.81. It's well known. Okay, your mass, you can weigh it. Weighing your mass, you know directly what is your mass. So what is your force? Simple, direct. But for much complicated one, let's say for example a mass of winds towards the building. What is the impact? What is the stress occur inside the building? So that must be a more complicated. So you need a more advanced tools. Okay. But when you talk about numerical, it yields approximate result. Okay. So that's why in this previous example, you can see that analytical, you have some difference with the numerical methods. So that is the approximate. So that's why we need to define the error. Okay, so you must have a very minimum error. Okay, so in order to know what to minimize your error, so you must identify your error. What is the error quantity in order to minimize your error? Okay, so this is the accuracy and precision. Okay, so what is the accuracy? What is the precision? So basically the error is representing both accuracy and imprecision. Okay, so error is comprising all of it, comprising your accuracy, precision, okay, accuracy and imprecision. Okay, alright. So Let's say for example, this pencils. How long is this pencil? Siapa boleh beritahu? Dekat A ni, dekat A, berapa panjang pensel? Berapa panjang pensel dekat A?
9 lebih. 9 lebih.
Salah.
9 cm.
Yang tu betul. Sebab kita ukur pakai berbaris. Yang dia terlebih-terlebih tu, that we call it as a error. That's why we need a B, the most accurate one. Ini kalau kamu zoom error sini, kamu hanya cakap baca ini 9.5. Kalau zoom lagi besar, then kamu punya detik dia lagi kecil, berapa banyak detik perpuluhan, lagi precise. Okay? So this is the important ones. Correct. Okay. So you must know what is significant digit, okay, and also significant figures. Okay, tahu significant? Ini saya rasa dekat admit dulu lah. Significant numbers. So you must know your significant numbers and your decimal point. Significant decimal point. Alright. So yang ni saya ulang balik dulu punya lah. Okay. So yang ni saya rasa hopefully semua tahu. Jangan tak tahu pula significant number tu apa. Jangan tak boleh dapat tangkap apa itu significant number. Boleh
Boleh.
Boleh ke?
Okey, boleh. Alhamdulillah. Okey. So, source of error. So, we have two types of error. We call it as a round of error. Second, we call it as a truncation error. Round of error and truncation error. Okay? So, the numerical error come from additional of round off with truncation error. So, round off error plus truncation error, that we have the numerical error. Okay? So, other than that, this error is not within our... It can be added, but it cannot be directly measured. So, we assume this is very, very small, or it's not directly related to numerical method. Okay, it's there, but we cannot measure directly. So the most significant one is the round of error and also the truncation error. So ada dua, round off dengan truncation error. Okay, so why measure error? To determine the accuracy. Okay, to develop stopping criterion. Okay, apa itu stopping criterion? Kita akan tengok. Kamu akan pakai banyak di seluruh dia nanti. Okay, alright. So, true error. So, what is the true error? True error atau biasa saya guna ET. ET true error. Error true. ET true error. Okay, alright. So, what is true error? So, this is your formula. True error divided by true value. So, in this case, you must know true value. True value. You must have the true value. From your true value, you can determine what is your true error. Okay? Okay. Another thing, rather than true error, we have the approximation error. Ataupun saya panggil biasa EA. Itu bahasa pasar. Jangan kata itu data designer yang buat-buat. Tak, ini bahasa pasar kelas kita je. Kalau orang lain tak tahu, mungkin dia panggil lain. Macam saya panggil EA. Ini bahasa kampung, senang. Nanti kalau saya pakai ini lambda ke apa ke, nanti kamu pening-pening. Senang, EA. EA, approximate error. Okay, so EA, approximate error, is your approximation error divided by approximate. Okay, times with 100%. Okay, so we have the ET, true value, true error, and then approximate error. Dan satu lagi we have the stopping criterion, ES. Okay, so ini catat awal-awal sebab kita nak pakai banyak di seluruh MEC 500 ni. Kamu akan jumpa 3 ni. Selalu jumpa. ET, EA, ES. ES, ET, EA. Okay, so what is the value of ES? ES we call it as a sorry. ES we call it as a stopping criterion. Yes, stopping criterion. So what is the value of ES? This is your value. So N is your number of which order. Depend on the how much order you want to stop lah. Okay, up to fifth order, letak sini 2 tolak 5. Depend. That is depend on the how much the accurate or how much stopping criterion you want to stop the equation. Okay, so kita ada 3 ET, EA, ES. Okay, alright. Boleh sebelum kita tengok contoh. Boleh?
Boleh.
Alhamdulillah. Alright, so we look into the first example. Let's say we have the exponential function. So dia banyak selain daripada exponential function, kamu ada Taylor series, kamu ada macam-macam series. Apa jua series, dia akan melibatkan benda macam ni. Sampai up to n order. Ini n order dia tu. Okay, dia simple. Okay, so here we have the exponential function that can compute using this equation. This is your equation lah. Okay, determine EX until approximation error solve at ES, stopping criterion, to confirm 3 significant digit when X is 0.5. Okay, so X is 0.5. Alright, so firstly you must know your ES. Because you want to know when you want to stop. Okay, macam kita buat analytical, kita akan stop bila dapat jawapan. Yang ni kita akan dapat jawapan tapi tak tepat. Kita akan ulang balik. Ulang sampai bila? Kalau kamu tak ada stopping criterion, kamu akan buat sampai bila-bila. Infinite. Sebab tu kita perlukan stopping criterion. Okay, so cari ES dulu. Okay, so this is your ES. So and dia bagi 3 significant digit, and 3. Substitute into this equation ni ES. Okay, masuk, dia akan dapat value. This is your stopping criterion. Okay, boleh? Boleh?
Boleh, sir.
Boleh, sir.
Okay. Sekejap, saya buka pen. Okay, so this is your ES. So ES kat sini kita dah dapat ES sama dengan 0.05%. Okay, so kita buat daripada nombor 1. Okay, first step. Okay, so first step, exponential ni, kita pakai ni X sama dengan 1. Okey. Nah, itu dia punya satulah. Okey. Direct. Because your x is equal to 0.5. Ini yang dia bagi ya. Okey, so maknanya E 0.5 1. Okey, masukkan terus saja dalam equation. Okey. So ini yang first. Yang kedua, kita ambil ini. Ini satu tadi ya, satu. Ini yang kedua. Okey, E X 1 campur 0.5. Macam tu. Okey. So kat sini kamu akan dapat 1.05. Okey. Okey. Yang kat sini kamu boleh buat dia punya EA. Sebab kita ada ES. So EA. Sorry. Tengok EA dia 1.5 tolak 1. Okey. 1.5 05, sorry, ini salah ni Jangan ya. 1.5. Dikali dengan 100. Okey, so dapat jawapan. Berapa jawapan dia? Inilah 33.3%. 33. Okey. So dekat sini boleh stop? Tak boleh. Sebab stopping criterion dia sampai 0.05%. So kena buat lagi. Nombor 3. So kalau 3 kita ambil sini sampai sini. Okey. So EX sama dengan 1 campur 0.5 1 campur apa lagi 0.5 kuasa 2 bagi dengan 2. Saya pergi kalkulator lah. Okey, saya tak ada kalkulator, saya tiru je jawapan. Macam ni. Dapat 1.625. Nanti minggu depan kamu bawa ni, kamu kena kira tau. Ni sebab ada jawapan, senang. Okey. So ni alright. Dah dapat macam biasa 1.625 tolak 1.5 bagi dengan 1.625 kali 100. So dapat dia punya EA. So EA dia berapa? Tengok jawapan, saya malah picit kalkulator. So inilah EA dia 7.69. 7.69%. Tengok yang ni 30, ni 7.69. Sorry. Tengok beza dia. Nampak? Kan? Dia jawapan macam ni lah. So bila nak berhenti? Sampai EA 0.05. EA. ET kamu kena ada true value. Macam ni dia dah bagi true value. Ni dia bagi true value. So kamu boleh kira ET. ET. Kalau ada. Kalau tak ada, tak boleh kira ET. Okey? Sebab yang penting adalah EA. Okey? EA approximate based kepada stopping criterion. So macam mana nak habiskan ni? kena buat sampai jadi table. Ini yang pertama. Ini kita panggil sebagai iteration. Iteration. So nanti kalau kamu buat FYP, buat simulation, kamu akan jumpa perkataan iteration. Inilah iteration. Satu iteration pertama. Kalau kamu buat iteration 1000, contohlah so yang ni sampai 1000 lah. 7 sampai 1000. So maknanya kalau iteration 1000, maknanya stopping criterion kamu sampai iteration ke 1000. Berapa persen lah? Very low lah. Okay. So ini kalau kamu tengok, kamu buat masukkan balik 1.5 iteration pertama, pertama, kedua, ketiga. Pertama, kedua, ketiga. Sampai sini dapat 769. So teruskan lagi 4 dapat 1.27, 5 0.158, 6 barulah less than ES. So yang ni baru kita stop. Stop maknanya that error is acceptable. Okay, stop. So maknanya kamu punya E value, exponential value is ni. Inilah value dia. Okay, 1.64. That is your exponential value for this this exponential function when x is 0.5 or 0.5. Okay. Okay. Alright tak? Setakat ni ada apa-apa soalan? Semua okey?
Tak ada.
Semua tak ada Bagus lah. Semua faham
Setakat tak ada ni.
Okey. Okey. So kalau tak ada, yang ni nanti kita akan masuk, yang ni kita akan masuk next week. Okey. So yang ni nanti saya akan bagi kamu contoh ataupun kamu kena buat latihan. Tengok saya buat seorang tak jadi apa. So kamu kena buat juga. Boleh? Boleh
Boleh sir.
Alhamdulillah.
Boleh.
Okey, so yang ni kita akan tengok minggu depan. Saya stop dulu sharing. Okey. Alright. So attendance jangan lupa sign Okey, so saya minggu depan lah